Okay, so I'm going to cover the space news as of today, June 5th. These initial pictures here highlight the Chinese Mars expedition. So we'll lead off with that. Tianwen-1 is the name of that. You know, they had been orbiting for a while. Now the lander has arrived and disgorged its rover. It went to a big open plain called Utopia Planitia. They picked that partially because there aren't too many rocks there, and partially because there's a lot of evidence of having subsurface water there in a frozen form, and maybe other interesting things. So it was a good place to land for them. So after they dropped off the lander and rover, the orbiter did continue its mission. So it's relaying the data back to Earth. The rover is called Zhurong, and this makes them the second country to succeed in putting a working rover onto Mars, obviously to the US being one. The Russians had tried and only lasted a minute or so. The rover is a little smaller than the US one. It comes in at 529 pounds. The US one's about 2,200 pounds. Pretty similar heights. The speed is about the same, or I should say the top speed is about the same. I don't know how much autonomy they have in their own driving, but a big factor in allowing faster exploration on the US version of this was having very autonomous driving. This is a 6-wheeled vehicle, also like the US one. It is solar powered, unlike the US one, which is powered by plutonium. Which has some good and bad points. Of course, it takes less weight, to get solar cells to Mars. The bad thing is that solar cells on Mars have problems with the dust in particular. We almost had the demise of the InSight lander that the US had put down a couple of years ago. It looks like, excuse me, it looks like they have succeeded in getting rid of some of that dust. But the dust is a constant problem for solar power there. In terms of instrumentation, it's pretty similar to what's available on the US one that's there now. They have 3D cameras, subsurface radar for picking up information about ice and other underground structures. They have composition analyzers, including the laser zapping kind of technique that we're using. The Chinese actually got a lot of help from the European Space Agency, French and Italians in particular, on some of the instrumentation that they're using on this. And they're all including a magnetic field monitors and a weather station. And that makes it pretty comparable in a lot of ways to the US current rover that's there for both of them. Their design life is just 90 days, but of course, like everybody else, they hope it'll go on for years, just like ours have. So the pictures that are shown here, the color picture in the lower left, that was pretty much the first one they sent back after they opened up the solar cells. They kind of folded out like a butterfly. You can see the on the left-hand side of that picture, one of those solar cell arrays. They also had some black and white photos up here showing the rover from the top of the lander looking down the landing ramp. And then after they went down the ramp onto the surface, they took a picture back. So it gives you an idea of what that looked like. As for the US efforts, of course, we reported on this before. There's the Perseverance Rover, which also included the Ingenuity Helicopter on Mars. And as to where that stands, the helicopter has made significant new records. They flew a 5th and a 6th flight. We only talked about the first 4 as of the last meeting. They flew at the maximum possible altitude, which is about 33 feet. And that's the limit of the laser altimeter that they use. They don't want to go above that because they wouldn't be able to tell their height at that point, or at least that's the stated limits of that instrument. They've now set the record for the length flown. The longest flight was the 6th one. It went about 700 feet. And also the flight lasted 140 seconds. The design flight time for this helicopter was stated as 90 seconds. So they've clearly exceeded that by quite a bit. They also went faster than they ever had before. They flew about 9 miles an hour. Now, we had reported they had previously said that the top limit was 8 miles per hour. And that was limited really based on their ability to analyze the photos they use for navigation. They use an inertial navigation system. What that is starting with a known position and orientation, just by measuring forces that you experience on a gyroscope and accelerometers, you can pretty much estimate your new position without any other sensor data. But the problem is errors build up over time, so you need to correct that. And on Earth, you can use GPS. They don't have GPS on Mars. So instead, they decided to go for a visual approach. They're just analyzing photos. So they take the photos, and the photos cover enough ground that you can predict, if you think you know your current position and the velocity and acceleration of where you're going, you can predict where you should end up at the next time you take a picture. And that's all within that same photo. So they can kind of establish a series of known points as they go along, which is kind of like the way surveying works on Earth right now. The British collected data all over the universe, all over the Earth, simply by taking known points and then going out there with their relatively primitive surveying equipment and establishing distance and angles from previous points. One thing they've done on this mission quite a bit is to collect stereo color imagery. That is really to support the role as being a scout. They've already proved that you can fly a helicopter on Mars. So the real issue now is, does it make sense to use it to scout ahead and look for places where it'd be a really good place for the rover to go, what path it should take, and so on. They did have a glitch on this one. This is the first time they had any kind of glitch at all. Midway through the flight, one of the navigation images they took disappeared. So that threw things off. I would call this an actual software bug. What happened was, when they missed one picture, that they threw off all the timestamps on the subsequent images. And the problem with that is that they didn't realize it, of course. So what happened is that they ended up overcorrecting. They kept thinking they were out of position when they really weren't. And as a result, the craft itself has to tip, because if you're trying to go in a horizontal or horizontal direction, the way you do that in a helicopter is you have to tip it. So the thing is constantly tipping itself. So okay, I've got a bunch of noise here all of a sudden. Anyway, they got oscillations up to about 20 degrees of pitch and roll. And they ended up landing the thing all right and went about 16 feet short of where they wanted to go. And that was close enough. I summarized that here as saying the safety system kicked in, but there's really several things that went right with this. First of all, when they designed the control system, they designed it with enough stability margin that they made sure that it could handle certain errors, and actually being off by 20 degrees didn't seem to hurt it that much. And the second thing is that as you actually start to land, you stop paying attention to those navigation pictures. And so the final landing didn't depend on the problem anyway, and as a result, they could land safely. As for where they are, we have this map of where's Perseverance, and now they've added where the helicopter is as well. So we look up here at the landing site. They landed up here where I'm circling right now. If you look hard, there's blue dots showing the original airfield for the helicopter. Anyway, the rover is starting now. It was moving around. It was off at a safe distance to watch the initial helicopter testing. But now it's really getting going on its own mission to move to a different area to start taking samples. So it's in progress. It's heading roughly south. And notice where the current helicopter position is. It's way ahead of where the rover is. So that's showing that it really can be used in a kind of a scouting capability. Back here on Earth, Virgin Galactic, they've done their first space flight test in 2 years. And this craft is called the VSS Unity. And it's really the second in a series that they generally call Spaceship 2. These are all suborbital space planes. And this is the third test of that type. And although it's a test, they did get some massive funding for some research payloads. So they're making a little bit of money in the process of doing this. But anyway, the way this works is they have this craft you see here on the left-hand side. They have a big carrier, which is kind of like two planes welded together. And in the middle, it carries the spacecraft. And here, this picture shows just after they dropped the spacecraft and the rockets are started up. And then that's a view, a more general view from above, an artist's conception. So anyway, they took off. They went up to 55 miles. And I should have said they released the craft at 44,000 feet. But anyway, they went up to 55 miles. And then they just glided back down and landed on a runway at the spaceport in New Mexico. And that sets some records right there, because that makes them the first humans launched from New Mexico into space. Now there's a question of, well, what is space exactly? Traditionally, we've usually heard this 100 kilometers or 62 miles. I'll talk about that in the next slide. So that one may be a little bit questionable. Anyway, commercial launches are still expected, maybe as early as this year, and their launches would have 6 passengers with 2 pilots and 6 passengers. So they have 3 more tests coming before they do that final commercial activity, though. The next one will have 4 passengers, and then they'll have a flight that will have Richard Branson on it, you know, the head Virgin Galactic guy. And then for some reason, the Italian Air Force has signed up for the next set of seats. I don't know why, but they did. The company supposedly has 600 reservations for tickets, and these are being sold for between $200,000 and $250,000. So it's a pretty substantial price. They seem to think they have a market for it. So you can bet that they're going to pick up their efforts and get moving as fast as they can here. So where did that space starts at 100 kilometers come from? It turns out there is actually some physical basis for it, which is what that was supposed to be. It's named after Theodor von Karman, who's pretty famous in aeronautical engineering in particular. And he came up with this by calculating that near this altitude, the atmosphere basically becomes too thin to support aerodynamic flight. You know, so you can fly an aircraft down in where the air is thick, and you can get lift by the proper shaping on the wing. As you go higher and higher, there's just not enough air, and at some point you can't even support aerodynamic flight. Now, interestingly, some other people apparently kind of rounded that up, because his original calculations were not actually up as high as 100 kilometers, but it kind of got rounded. So we would say, well, it's near this area. Some more recent calculations have been done suggesting that actually 84 kilometers would be about right, which is 52 miles. And that actually apparently is pretty close to von Karman's original estimates. There are some other things that go on in the atmosphere in this region as well. For instance, there's a very rapid increase in the temperature as you drop down below 100 kilometers. It really tends to heat up. There are some people that care about this boundary, the so-called boundary of space. One is it's called the World Air Sports Federation in English. It's actually abbreviated FAI for it's in French. That's used when they want to say, well, okay, how many astronauts have been there and so on. But it really has more than just a sports kind of an issue. It may get involved in treaties. I mean, for instance, you think about countries like the US, China, and Russia. We take our airspace very seriously. And when people fly over it, I mean, we reserve the right to shoot them down. So it kind of matters just where those altitudes are. And I forgot to mention one other thing that also defines this region of space on the boundary is that 80 kilometers, that's about the lowest that a satellite can go and still complete an orbit. So that's even in an elliptical orbit where, you know, it only comes in and is briefly at that low altitude. But any lower in altitude, and what happens is the air friction just overcomes it. It won't make it a full revolution. And that may be why the Air Force actually had picked a number close to that as well. Some of the early flights, like the X-15 rocket planes, they were really around more that 50-mile kind of range. And so we've actually given people badges saying they've been into space. The Air Force has done that quite a bit. So there's still an argument going on as where does space start. Obviously, it's somewhat of an arbitrary line, but there are some physical principles involved. One is aerodynamic lift. 2 is ability to have a satellite in orbit without just crashing due to air friction, and 3, temperature changes. So there's at least 3 different reasons for establishing a boundary in that general area. Okay, now we get fairly quickly to how many launches have there been since the last meeting. And remember, these are only the launches that attempt to go as high as orbit or beyond. So that rules out the Virgin Galactic one, for instance, which, you know, that's only suborbital. They're not intending to make a full orbit. So if people want to try to vote on this, we'll let you vote for a few minutes here, and we'll give you the results. Okay, I'm not seeing any votes. Maybe I have a problem with my. I'm going to skip that. Anyway, the right answer is 11. And I'll highlight a couple of interesting things on that. The first one is that, well, SpaceX has been very busy with our Starlink. they've now, in this last period, they put up 4 different batches of satellites, and that's about 60 satellites each time. One of those launches happened to have a couple of small rideshare satellites, so they didn't quite do 60 on every single one, but still that's 238 satellites in 4 launches in 1 month. Pretty impressive. Another interesting one is I'll move down here toward the bottom, the second Chinese launch toward their new space station. Remember, they had launched the initial modules they put up there last month, and in fact, then they had problems with the ship kind of crashing to Earth. Luckily, it fell down in the ocean, didn't hurt anybody. That one's unmanned. It's just basically putting up crew supplies and so on, but it did actually dock automatically. So now that space station is bigger now that that module has been added. Another one I'll point out is that OneWeb, which is another internet service company. They now have 218 satellites up there because they launched a bunch of them on the Soyuz, the Russian rocket, to get that up there. Remember, that company is actually currently jointly owned by the UK and a private Indian company. And that's I think that's all really of major interest here. Other than the last comment, there was a resupply mission to the space station on a Falcon 9. Using the cargo Dragon, which has been redesigned to be a little bit bigger. An interesting highlight on that one is that they use a new booster for that. And that was the first one this year. And that's out of 17 launches. So it used to be that every single rocket ship, including boosters, every piece of the rocket ship, including boosters, was brand new and just thrown away. Now it's kind of gone the other way, and it makes news when you actually have a new booster being put into service.
Greg, one thing is the actual voting did come up. We had 10 people voted, and people are getting very good about the guessing. We had one person get it right on the 11, and 3 for 10, and 2 for 9. So, and then everybody else below that. So,
well, I guess a hint is that quite often around 10 or 11 is a pretty good guess. It seems like it may pick up later this year, though. So that may be. Those numbers might start to get to be low. There was a period there where things slowed down because of COVID-19, and that's gone now almost. At least among us anyway.
Well, and if SpaceX is even half as successful with the Starship as they want to be, it might be in the thousands at some point.
Yeah. Okay, any other discussion items or questions?
I have a question.
Yes.
The great majority were satellite launchings. Is that business as usual, just to upgrade all the satellites?
Yeah, is that business as usual? Yeah, I would say that's pretty much, that is still the biggest single customer of launches is satellites of all types. Now that includes internet service, now with Starlink, but really it traditionally always included commercial and government use of, observation. They call them Earth observation satellites. In the old days, you call them spy satellites, but it's really not spying necessarily. It's everything from estimating growths of forests to, monitoring forest fires for that matter.
Greg, do you think that the rise in the number of customers for all these sites like Facebook and that, do you think that's driving this this rash of satellite launches, or is it the reverse? Do they launch the satellites and hoping to get more clientele?
Well, yeah, I'd say it's more the latter. SpaceX, it was pretty clear. The launch, as a launch business, the total, revenue from that isn't really all that great. And that by itself, for instance, Elon Musk will never be able to get to Mars because he wouldn't be able to grow the company fast enough. So he decided just to speed the business up, he would launch his own his internet service. That is probably going to generate 10 times as much revenue as the launch business itself. But of course, then again, that overlaps because he's generating his own launch business. It was kind of handy because it also gave him a chance to prove to everybody that you can, use reusable rockets and boosters, and they were willing to put their own satellites on the line to show it. So basically, everybody assumes the business will materialize. There was no guarantee that would be the case. Iridium years and years ago was going to do the same thing. They said, let's put up satellites and we'll have internet service all over the whole world and everybody will use it. Well, it turned out everybody didn't use it, mainly because the cell system got so much better, so much faster than anyone expected. They didn't need satellite service except as a niche market, in really remote places like Antarctica or out in the middle of the ocean, or for spies, those kind of things. So I would say people are definitely building it ahead, assuming that the demand will be there. And by advertising that they have it, they're trying to create that demand. Any other comments or questions? Okay, I guess I'll move on to introduce the speaker. Masa Esmondabali. She's going to talk about the Sasakawa International Center for Space Architecture. And what is that? Well, it's a very unique research, design, and teaching organization associated with the University of Houston. Founded in '87 by an endowment from a Japanese shipping magnate named Ryuichi Sasakawa. And their mission is to plan and implement programs to advance peaceful and beneficial uses of space and space technology. So they are a leader in space architecture. The speaker, Masa, she has been involved in this, and she is a graduate of that program. She started off as originally as an architect herself, but she's gone off and gotten very involved in designing habitats and greenhouses in several different space environments: Mars, with its low G, Moon with a super low G, and zero G environments of orbit. And she's published quite a few papers worth looking at. They're kind of interesting, covering, again, these different areas, and also even looking at some traditional structures and how they might apply to use in space as well. On the AIA, which is Aeronautics and Astronautics Engineering Organization, she is on the Space Architecture Technical Committee, and she's also gotten involved a little bit in, she's in mission support now for the Mars Society's project for their Mars Desert Research Station. This is a kind of a simulated Mars environment in the Utah desert. She has 10 years of experience as an architect, as a project manager, and assistant professor. And she has done work, for instance, locally for a traditional architectural company called Allraj Architects here in Houston. She is on the board of directors of the Space Society, and she has master's degrees in architecture, architectural engineering, and in particular in aerospace architecture through the SICSA, the Sasakawa Center. So with that, I'll turn it over to Masa.
Thank you for the great introduction, Greg. It's great.